So this machine that you see behind me here removes as much CO2 from the atmosphere as about 100 trees. Our more scaled up versions remove as much as 1,000 trees per year from the atmosphere. And you can already see that, like, to plant 1,000 trees, you would need about 10 hectares of land. Like this machine and like the machines like it that we build, like, have a very minimal land footprint basically, which also make it a very scalable solution in addressing climate change.
So this is one of the machines we use to capture CO2. We call it Lenana. The process is basically divided into a capture phase and a release phase. In the capture phase, we pass a volume of air through the machine, facilitated by a blower and a fan at the top. And as air passes through the machine, there is a filter inside that selectively captures the CO2. We monitor the concentrations, and once the filter is saturated, we seal off the machine, create a vacuum, and then heat up the filter to facilitate the release phase. Once all the CO2 has been released from the filter, we move it into a buffer tank before compressing it into cylinders.
Our hope is to demonstrate that this cost, like that this technology can actually come down the cost curve, and that it can be a lot more feasible as we build and deploy it basically. And as we do that, I think we really hope that it will sort of create a real hope in the fight against climate change. Hope that there is a way for the world to actually, like, affordably hit net zero, and that we don't sort of have to drastically change our lives to get to that point basically. And that hope is really like what we are building these machines for.
One of the major challenges with carbon capture is that it's an energy intensive process. You need a lot of energy for the process. For example, 85% of our needs in the machine are thermal energy. And in this case, the way we are trying to solve for that in Octavia Carbon is that we are trying to tap into using geothermal steam or geothermal waste heat, which comes at a very low cost.